Okay, now we will see the degree of dissociation. Now we will see the degree of dissociation. So the degree of dissociation is equal to, so degree of dissociation. So we are calculating the dissociation of the strong electrolyte and the weak electrolyte. So number of moles of electrolyte ionized. So what is the ratio between the number of moles of ionized electrolyte ionized to the total number of moles of electrolyte taken? Degree of dissociation is a ratio of number of moles of electrolyte ionized to the total number of moles of electrolyte taken. That is called degree of dissociation. For example, if you take that electrolyte total number of moles 100 for example. So in that 50 moles only ionized. So total number of moles ionized, that is a 50, but total number of moles in the electrolyte taken 100. Okay, so that is the degree of dissociation. That is a degree of dissociation. In case of weak electrolyte, there is a equilibrium exist. There is a equilibrium exist in between the unionized particles and ionized particle. So what is the meaning of equilibrium existed? So that ionized particle convert to unionized, unionized particles convert to ionized. Suppose if you take that acetic acid. So this is a before, this is unionized. So not dissociated. This is a ionized. So these are separated. So this equilibrium in between the unionized particles to the ionized particle. So in the weak electrolytes, in case of weak electrolytes you can see. And next one more thing, for strong electrolyte, degree of dissociation is nearly equal to the 1. So completely that is undergoing dissociation or ionization. For weak electrolyte, the degree of dissociation is very low, that is less than 1. That is the degree of dissociation for weak electrolyte, that is very negligible, you can say. Is it clear? So degree of dissociation is the ratio of number of moles of electrolyte ionized to the total number of moles of electrolyte taken. In the weak electrolytes, there is a equilibrium exists in between the unionized particle to the ionized particles. So for strong electrolytes, the degree of dissociation alpha, we are indicating the alpha, that is nearly equal to the 1. For weak electrolyte, that is very negligible 1. Okay. Now we will see what are the factors affecting the ionic conductance. What are the factors affecting the ionic conductance? First we see that inter-ionic interactions. So what is the meaning inter-ionic? So within the ions, inter-ionic attractions decrease. Solute interactions. What are those? Solute interactions. So decreases the number of free ions in the inter-ionic attractions. Solute interactions increases, the number of free ions decreases, consequently electrolytic or ionic conductance decreases. So in the inter-ionic attractions, the solute interactions will become more, so that causes the number of free electrons decreases. So consequently what will happen? Electrolytic or ionic conductance decreases. Next, solvation. So what is the meaning of solvation? So one ion, either cation or anion, whatever. So suppose if you take that Na plus ion, for example, what is that? If you take that Na plus ion, in the Na plus ion, they are surrounded by the water molecule, solvent. Let's take that. So this is surrounded by the water molecule. Next we see, take that Cl minus. Already here. If you take the Cl minus, so the interactions will be there like this. So these surrounded by the water molecule. So solvation means the ion which is surrounded by the number of water molecules. So ion dipole interactions increases. Ion dipole interactions increases Because of that one, solute solvent interactions increases. What will happen? Solute solvent interactions increases, then electrical conductance decreases. Electrical conductance decreases. For example, if they ask that which of the following have the highest electrical conductance? Lithium in aqueous state, lithium, sodium, potassium, rubidium. They may ask for example. So which of the following have the highest ionic conductance? So ionic conductance is inversely proportional to the size of the ion. What is that? Ionic conductance is inversely proportional to the electrical conductivity. No, sorry, that. What is that? Electrical conductivity. So now we will see that ionic conductance is inversely proportional to the electrical conductance. See that ionic size is inversely proportional to the electrical conductance. So which is having the more size? So in solvent generally lithium plus we are taking Na plus K plus rubidium plus. So which is having the smaller ion La plus, which is more solvated, and La plus have the more ionic size, which is have the smaller ion, that is the more solvated, that will become more size. So ionic conductance is less. So which is the higher size ion, that is less solvated, that is having the more electrical conductivity. So La plus less than K plus. So rubidium plus is having the highest electrical conductivity because of less solvation. Because maximum size of the atom. So solvation, in the solvation, after the solvation, which is having the more size? La plus having the more size than Na plus more than K plus more than Rb plus. Is it clear? So this is the electrical conductivity order. Ionic size order: La plus greater than Na plus greater than potassium plus greater than Rb plus. So this is a solvation order. So this is a more solvated, more bulkier. It cannot have the more ionic conductance. So which is less solvated? This is a solvated ions. So ionic size which is more lithium plus. So electrical conductivity less. Next come to the viscosity. So solvent interactions increases. What is that? Solvent interaction increases. Ions cannot move freely. Electric conductance decreases. Electrolytic conductance decreases. Next, temperature increases. Kinetic energy increases. Ionic conductance is also increases. I will repeat once again. Factors affecting the ionic conductance. First one, inter-ionic interactions. So solute interactions are more. So number of free ions decreases. Electrolytic or ionic conductance decreases. Next, solvation. So the number of water molecules are surrounded by the ions. So number of water molecules surrounds the ions. So Na plus ion is surrounded by the H2O molecules. Like Cl minus ion is also surrounded by the water molecule. That is called solvation. So ion dipole interactions, because of the ion dipole interactions increases. So solute solvent interactions increases. Finally electrical conductance decreases. So this is order. For example, lithium, sodium, potassium, rubidium, they are given in ions is aqueous state. So rubidium plus shows the more electrical conductivity because less solvation, because more size. Lithium plus is a less electrical conductivity because more solvation. So this is the ionic size inversely proportional to the electrical conductivity. So lithium plus, Na plus, potassium plus, rubidium plus. So this is the order of solvation. Which is more solvated, that is a less electrical, shows less electrical conductivity. Next, viscosity. Because of the solvent-solvent interactions increases, ions cannot move freely. Ions cannot move freely. Automatically, the electrolyte conductance decreases. Next, temperature increases. Kinetic energy increases. Ionic conductance increases. This is the factors influencing the ionic conductance.